I want to look at this idea of completing the square. So, same questions we had yesterday, sketching the parabola, but alternative ways of finding the information. As I say, first technique, completing the square. So we've got x squared plus 8x plus 12, but instead, if I complete the square, now whenever we complete the square, it's always x plus half the coefficient of x, all squared. So in this case, half the coefficient of x is 4, so I know it's going to be x plus 4 all squared. But if I was to expand that out, I'm not going to get 12, I'm going to get 16. So to make it correct, I need to subtract another 4. But when it's written in this form, I can read it like we saw when we were moving curves to the left, up or down, because now it's grouped with the x plus 4, so that tells me we've shifted it to the left 4 units. And then we've also got this negative 4 at the end, which tells me I've shifted down 4 units. There's the vertex. So an alternative way of finding the vertex where I didn't have to use the axis of symmetry, in fact I didn't even have to find the axis of symmetry because I know it's going to be negative 4. So there it is, negative 4, negative 4. The x-intercepts, well, I'm not suggesting you would do it this way, but if you had completed the square, then now what we're really saying is, well, when is x plus 4 all squared, minus 4 equal to 0, and I can move the 4 over, square root of 4 plus or minus 2, so we know it's going to be negative 4 plus or minus 2. There we go. Write down the quadratic. Okay, so again, same question as yesterday. With roots 2 and 8, and the vertex is at 5, 3. Well, if the vertex is at 5, 3, then I know it must have been x minus 5 all squared. But it could be some constant times that. But also, we've shifted the curve up 3, so there is a plus 3. But notice the constant is only times the x minus 5 all squared. It's not times the 3. Because if we times it by the 3, that would then change how far we shifted up or down. Well, we know it's got solutions 2 and 8. Well, I really only need to use one of those. So I used 2, 0. That got me that k is negative a third. And just like we saw yesterday, righto, that means my parabola is minus a third, although I've left it in the completing the square format. If you were to expand it out, we would get the same as we saw yesterday. Okay, so that's using the idea of completing the square. Another thing we can use is a thing called the discriminant. The discriminant is simply that bit under the square root sign in the quadratic formula. So b squared minus 4ac. And we'll see some more uses of this later on. But the thing I want to look at here is you can actually work out the y value of the vertex without actually having to know the axis of symmetry. It'll always be minus the discriminant on 4a. So if you've got one of those questions where it says, what's the maximum or what's the minimum, then I could use this, because remember, maximum and minimum is simply what is the y value. Don't actually need to know the x value. So it's a handy thing to know. The zeros then, of course, well, it's the solution to the quadratic equation, so plus or minus the square root of the discriminant there. Now, if the discriminant is less than 0, that means in our quadratic formula we're going to find the square root of a negative number, which of course we can't do. So that tells us our graph will have no x-intercepts. If it was equal to 0, then we'd be saying plus or minus 0, so we must have only one intercept. So that's one of the ones where the parabola just touches the x-axis. And if it's greater than 0, then we would end up with two solutions, because we would have plus or minus whatever that square root is. So back to our question from yesterday, x squared plus 8x plus 12. The discriminant for that one turns out to be 16. So the vertex, well, minus b on 2a, but now I can simply say for the y value, minus the discriminant on 4a. So minus 16 on 4. And sure enough, we get our answer of minus 4, minus 4. Okay. So 8b is somewhere completing the square will be a handy technique. 8c, discriminant. And you might mix and match the ideas. It doesn't mean to say you have to use completing the square for everything. You might just use it for one part of the question. You might use a discriminant